All right, today we'll be going over Hess's law. So Hess's law states that the overall enthalpy change, that's delta H right here, in a reaction is equal to the sum of the enthalpy changes for the individual steps in a process. So basically, for each of these problems, we're going to get this main equation, right? So this is kind of our goal. We're trying to get to this equation, and we're trying to find the delta H. And so this main equation is made up of these smaller steps, okay? And so our goal is basically to try to get these smaller steps to look like this main equation over here. So we can do that in a few ways. We're going to manipulate these smaller steps here and try to get it to look like that main equation. So how do we do that? So let's first start by recognizing, what are the common things we see here. So here I've got 6 carbons and C6H6, that's benzene. Those are both present in that main equation we're trying to get to, but they're on the wrong side of the equation here. So what we want to do is we want to flip these around. Okay, so we're going to rewrite this and flip it around so that these chemicals are on the correct side. Now the chemicals are on the correct side, but since I flipped the equation around, I'm also going to kind of flip this number. So instead of positive, it's now going to be negative 78 kilojoules per mole. Okay, so next we look at the next equation, and we see that water is present here, right, and water is present here. However, we're trying to get to 3 waters here, and here we only have 1. We also have 3½ O2s, and we only have 1/2 O2 here. So what I can do is I can multiply this whole thing by 3. So I'm going to go ahead and do that and rewrite this equation. Now I have my 3 waters. I also need to multiply the delta H by 3. So this becomes negative 74.4 kilojoules per mole. Okay, at this point, I can go ahead and combine my 2 equations here. And what happens is any product that's formed, or anything you see on both sides of the equation, so here we see H2 is on both sides, that's simply going to cancel out. And what we're left with is our final equation, right? This is what we had wanted. So we have our final equation. Now we can find the delta H by simply combining these 2 numbers here. So we're just going to add those 2 numbers together, and this would be our final answer. Okay, if you flip to the other side of the worksheet, we can look at a few more problems. So in this first problem, you'll see that NH3 is on the correct side and it's in the correct number, so you don't have to change that. NH4Cl, again, correct side and the correct number, you don't have to change that second equation either. And then HCl is also on the correct side and the correct number, you don't have to change that. So really, you just have to add these numbers together and that'll give you the answer. You can combine these, but you'll see that you end up with those 3 chemicals that we want, and it turns out everything else will just cancel out. So 1½ and 3½, that's 2 hydrogens total. That'll cancel out with these 2 hydrogens here. Half a chlorine cancels out with that half a chlorine. Half a nitrogen cancels out. And like I said, we'll be left with the equation that we wanted. So all you have to do is add those up for the number 1. Let's go over number 2. So here, we'll just follow those same steps that we did. So C2H4, I see over here, it is on the correct side and the correct number, so I don't need to change that first equation. Here I have C2H6, we've got C2H6 here, but it's on the wrong side. So what we want to do is flip this equation around. I'm going to rewrite it. 2CO2 plus 3 H2Os. And remember, whenever you flip an equation around, when you switch the sides, we're going to change the sign on the delta H as well. So instead of negative, it becomes positive 1560. So I don't get confused, I'm just going to go ahead and cross this out now so I know not to look at that. Okay, next we've got hydrogen, and I've got hydrogen here. It's already the correct number, so I don't need to change that equation either. So at this point, we can combine our steps here, and we'll see that, let's see. We've got 2 plus 1 water, so 3 waters total will cancel out with these 3 waters. I've got 3.5 oxygens, 3.5 oxygens here, those will cancel out. 2 carbon dioxides here, 2 carbon dioxides here, those cancel out. And again, we're left with the chemicals that we want in that final equation. So we can rewrite it. And you would go ahead and just add these 3 numbers here to get your answer in kilojoules. All right, so that's how we do Hess's law problems. Just to recap, you can do a few things, right? You can flip an equation around to get the reactants and products on the correct side, or you can multiply by a number to get the correct number of products or reactants. All right, feel free to ask me questions if you have any about Hess's law.